Hello and welcome back at this stage. I'm very delighted to welcome now together with all of you Carola Lilienthal. Carola is an active member of the iSAQB and managing
Yes,
director of workplace solutions.
thank you,
For
Mirko.
many, a bit more if you like.
Yes, go.
Okay. For many years, she has been analyzing architectures and advising development teams and how to improve the longevity of their software systems. And yeah, Carola is also author of many articles and books in the field of software architecture. And as a member of the advisory board of the Software Architecture Gathering, Carola was a key player in putting together our program. My big thanks goes to you for this, Carola. And now the stage is yours. Thank you.
Thank you, Mirko. Thank you very much for this nice introduction. So, welcome to my talk on domain pattern. This is the first time I really talk about that, and I hope to reach out to all of you who are listening outside with this, for me, quite new and very interesting idea. So let's start at the beginning. Back in 2004, I have read Eric Evans' book on domain-driven design, and this talk is related to that. This is why I start with Eric Evans. And at that time, I instantly fell in love with this idea to follow the domain when designing a software system. And one of the recommendations in this book was that the architecture should be structured according to the domain and its subdomains. And since 2004, I follow this advice in my projects. And when helping clients to build well-structured software systems, I do it as well. When analyzing domains according to DDD, to domain-driven design, we encounter often domains that are very easy to split into subdomains. And we find domains where it was significantly more difficult to find subdomains. And that was the moment when we started to think about domain patterns, which is the title of this talk, and how the domain finally influences the architecture. So in this talk, I will present to you my thoughts on domain patterns and their implementation, and I hope to have some discussions and feedback with you afterwards. My company is called Workplace Solution, WPS. We started in 2000 with 12 developers, and we have been growing since then to 170 developers all over Germany. We are using domain-driven design since almost 20 years, actually, and we develop all our software. And the software we try to develop is a software that makes our users really happy because it's really supporting the domain. And our software often makes the architects happy too, because the architecture is in good shape. And that, in the end, makes managers happy as well, because the maintenance costs are significantly less than with unstructured systems. Since microservices entered the scene around 2012, we have helped many clients to transform their legacy systems towards a more modular, future-proven architecture following the domain. And based on this experience, we eventually combined our knowledge in several books. The first one was on sustainable software architecture, in which I explained how to analyze, reduce, and avoid technical depth to get a sustainable software architecture. After that, my colleague Henning Schwendner and I, we translated actually the English book, Domain-Driven Design Distilled by Vogt into German. In 2021, my colleagues Henning Schwendner and Stefan Hofer wrote their book about domain storytelling, in which they introduced a lightweight method that combines a simple graphical notation with a workshop format to capture business processes and find subdomains. And finally, Henning and I, we combined these 3 topics and completed this summer the German version of our book, Domain-Driven Transformation. The English version will come out next year, so the translation is on its way. And I hope you will enjoy that book too. What we deal with when we help our customers to improve their legacy systems with domain-driven transformation is actually this. Our customers' daily work is characterized by legacy systems that look like this thing here. Difficult to understand. Well, what is it? Difficult to change. I mean, where should I start? And difficult to extend, of course, as well. And why is this the case? Well, you all know that. The system has been developed over many, many years. New parts were added every year, often at a very rapid pace. And since the developers didn't have time, only the new parts were programmed into the system. The older parts were not adjusted properly. And so the architecture got worse and worse step by step. The architecture eroded, and inside of the system, we find structures like this one. This is a large entangled class cycle with 463 classes belonging to 10 different components. Each rectangle here is a class in Java, and the colors of the rectangles indicate to which component a class belongs to. The relationships between the classes are represented by the arrows between the rectangles. As you can see, there are many relationships. Especially in the middle, everything is full of arrows, so that some areas appear almost black. It is impossible to remove a class from this cycle because other classes need it. Or impossible is maybe too much, but it is really hard because you have to understand the context and have to find out how the other classes will react. And there are a lot of them, of course, because the whole cycle is a tangled structure. In domain-driven design, we call this a big ball of mud. It's a so strongly interwoven structure that you don't find your way around, you don't know where it starts, where it ends, because everything is interwoven in this structure. With domain-driven transformation, we have described a method that provides guidance for the decomposition of a big ball of mud and for the transformation to a modular architecture. The domain-driven transformation consists of 4 steps at the strategy level. The first step is domain rediscovery. The second step is modeling the to-be, so the future. The third step is aligning as is, so the status as it is now, the present, with the to-be, with the future. And the fourth step, of course, is do it, do the move. Okay, but what does this mean? Can we have an example, please? Yes, of course. Let's take an example from the leasing domain. A team the other day asked us to help them to decompose their aging legacy system, their aging leasing system, so a system that supports the leasing of cars, with domain-driven transformation. What did we do? How did we start? Well, step 1, domain rediscovery. This was the starting point. The first step of the domain rediscovery is tackled in a workshop with the development team and important key users. So this is actually the important point. You need some key users, some people who really understand the domain. And we do this without thinking about the current software system. We try to model the process of leasing a car together with the domain experts, the key users, and the development team. And the result of this workshop is normally a series of domain stories that describe the work of the users in their domain. As an example, let's take a closer look at the conclusion of a contract for a leased vehicle. We have 3 people that are involved in this leasing process: the customer, the salesperson, and the risk manager. The process begins with the customer that informs the salesperson of their wish, which kind of car he needs. The salesperson then calculates the installment and for the contract, and the customer then signs the contract. After this, the salesperson passes the signed contract onto the risk manager, and the risk manager now checks the credit rate, he calculates the real sale of the car, and he votes the contract if everything is okay. So this is the process if everything is okay with the idea of this leasing contract and the calculation is right and the risk manager is happy with this contract. And finally, the salesperson hands over the car to the customer. Of course, many details are missing in this domain story that we would include in a real domain rediscovery. For example, the individual steps are missing when the salesperson suggests different models of cars to the customer and offers discount and special rates in his sales pitch to convince the customer of his offer. But, well, it doesn't all fit on this slide, so we live with this simplification in the end. We now take this domain story as the basis for breaking down the domain into subdomains. This domain story contains of 2 subdomains, the subdomain sales and the subdomain risk management. This is the perfect domain-driven structure for our domain that we want to use as the domain-driven architecture for our software. In domain-driven design, this is shown with a context map. The 2 contexts, sale and risk management, are 2 core domains that any leasing company will have. If we dig a little deeper, we will find some other subdomains, such as price calculation, risk reporting, and of course, payment is necessary in here. This was the second step, modeling the to-be. So we have rediscovered the domain with the domain story, and then we modeled the as is. So we modeled not the to-be, but we modeled the future. I'm sorry for confusing you. We modeled the future. This should be the future of our architecture, the to-be. Unfortunately, this structure of subdomains often does not fit together with the source code of the legacy system at all. So we have to get into step 3, aligning as is with to be. If we have identified the subdomains with our domain experts and compiled them into our context map, we can start this alignment. On the one hand, we have the to be structure of our system in the context map. And on the one hand, we have a software system with probably several modules. Let's call them module A, B, and module C. If we superimpose the context map and the modules, we see that module A and B each cover functionality from 2 bounded contexts, and module C even serves all 3 bounded contexts. So the intersection of the modules does not fit at all to our context map. It's pretty obvious that we have a problem and that it will be hard work to change our software towards this context map, this to be. If you look at the strong interfaces between the modules, the dark connections, it becomes clear that the division into these modules was not done with loose coupling in mind. Domain-driven design actually is heading towards loose coupling. Bounded contexts, which should actually represent a structure of high cohesion in the context and loose coupling between the contexts, is not present here. The module structure must therefore be fundamentally questioned anyway. And this is, of course, an extreme example, I must admit, but I wanted to make clear the difference between the as is and the to be. To find out how well or how poorly the modules, the modularization has succeeded in the as is, we measure the system with the modularity maturity index. The modulary maturity index is an index that gives system with poor modularization a score between 0 and 4. Systems that are rather mediocre get a score between 4 and 8. And systems with a good modularization get a score above 8. Here you can see 21 systems that we have measured with the modulary maturity index. The sizes of the points correspond to the sizes of the systems in lines of code. From left to right, the systems are arranged in according to the time at which we measured them. So we started with the little one, the little red one down there, and then we did the big green one, and then we did a yellow one, and so on. If you need an explanation how we got to these results, you can look into the book Software Architecture Metrics, where I had the chance to write one chapter, and there I have explained in detail how to come to these results. The thing that you have to remember here is there are systems that are very bad in their modularization. There are some systems that are yellow, so in between, and there are as well systems that are very good, that are green. The most common diseases we find in these legacy systems that are red are the aforementioned big ball of mud. I already talked about that. Another thing we find very often are anemic domain models. I will come to that later. And what we see as well very often are bad structured teams. In our book, we show cures to combat and heal these diseases. The best way to fight the big ball of mud is strategic domain-driven transformation. The best way to get rid of the anemic domain model is tactical transformation. And you can transform a bad team organization into a focused, powerful team with some socio-technical advice from our domain-driven transformation book. While we dealt with the while we were doing this domain-driven transformation, we found out that we have different domain patterns in our software systems, in our domains. This is what I talked to you in the beginning. And to get in contact with these different domain patterns, we added another chapter in our book. And there we found different dimensions to analyze domain patterns and I will explain this now to you. The first dimension was, how is the workflow in the domain organized? We looked at this dimension because there are subdomains that are easier to decompose, and there are subdomains where it's really hard to decompose them. The second dimension is, how is the domain model implemented in the software? We look at this dimension because there are implementations of domain models that make it much easier or harder to decompose the legacy system. And the third dimension is, what is the shape of the domain? We look at this dimension because the evolution of the domain and the software influences each other, and the legacy software is different to decompose depending on the state of the evolution. Let's start with the first dimension. This dimension is about how the users organize their work and their cooperation. What do they do on their own and what do they do together? In this dimension, we have identified 3 domain patterns: the pipeline domain, the Blackbird domain, and the dialogue domain. Let's have a closer look at each of them in the following slides. If the work in a domain is done step by step, partially also by different roles, this domain follows the domain pattern pipeline. The steps have an order, and it is clear that the later steps cannot be done without the steps before. So there is an order 1, 2, 3, 4, and so on. Each role completes a work step and passes the work result to the next station, so to call, to the next role, where someone takes this work result and does some further processes on it. So the next role uses the result of the first or the former role to continue with this work. Typical representations of these domain patterns are, in virtually every domain, parts of pipeline-like operations can be found. If you think about it, logistic processes are very often like this. You have the customer who asks for some goods, and then the goods are prepared in the stock, and then they are put on a boat or on a vessel, and then they are put on a truck, and then maybe at the end there is some lorry who brings the goods to your house. So this is a typical example for the pipeline pattern. Another one is purchases and delivery processes, or trading on trading platforms where there are clear steps that are performed one after the other. Or as well, a conclusion of an insurance or a credit contract. The leasing example was a bit like that as well. Regulatory processes in the administration in your country follow the pipeline pattern as well. You have to hand in some form, then the form is checked, and there's a signature or a stamp on it, and then it goes on to the next post who sends you another paper, and so on. A cinema example, cinemas follow that same pipeline domain pattern. At first, the program is organized, and then tickets are sold, and then you get into the cinema. So there is a clear step-by-step proceeding. The leasing example, offering and risk management are as well from this pipeline idea. So virtually in every domain that you have to deal with, parts are pipeline-like, and you can find it either on the top level of the domain, or you find it in smaller bits and pieces of the domain. So domains that follow the pipeline domain pattern, these domains can be analyzed and decomposed relatively easy with domain stories or event stormings or other techniques. And this is because the slices in the business domain, as we have seen in the leasing example before, they are directly visible as steps in this domain. I think this is certainly the reason why in conference presentations and in books, the authors and the speakers, they like to use examples of domains that correspond to the pipeline pattern, because it's so you can just show it to people and they really see the steps and the cuts and the bounded contexts and subdomains in there. Much more difficult to analyze and decompose are domains where the various users work together, or the various roles work together with the software on one or more business objects. We have called this domain pattern blackboard in reference to the blackboard architecture of Frank Bussmann, who wrote this in several domain pattern books. With this blackboard pattern, an analysis of the work relationships between the individual roles does normally not reveal some sequence that is in there. There is no sequence of activities. You can see that in this little pictograph I have designed for this kind of domain pattern. There is a blackboard in the middle, and the roles all work all together on the items. So the overarching coarse granular process, so the overall process consists of activities that are not performed one after the other, but in parallel. So the roles, someone is doing something with a work object, and then the next one reacts to the data, changes something, and then the first one has to work again on the same work object. Some examples for this. I don't know if you have ever seen this domain, but we have sometimes looked into. I'm sorry, something horrible happened here. I'm back.
Okay, great.
You can hear
Thank
me.
you.
I'm really
yeah,
sorry.
we can hear. No.
I'm really sorry. I don't know why this happened.
Just 1 minute.
Someone stepped on my. I'm on my cable. I try to re-share my slides. Here they are. And we just keep going. Sorry, people. This was, I don't know. Someone stepped on my cable. So I was just talking about your calculation software for cars. I guess you understood. I remember when we went off that different roles work together on the plan for the machines, for the cars, for whatever. I'm really sorry that this happened, that I was gone. The next example is, I don't know if you ever did that, but planning for a major event management with different roles who plan the conference, some dinner, the show in between. All this is rather complicated, and in the sense complicated, there are no steps where you have finished something, but even 5 minutes before the conference or in the conference, someone can just go off like me, and you have to change something in your program. So different roles are all working together on the plan. Next example, if you are in a control center and you observe and monitor the different plants, the logistic processes, the traffic flow, there are as well different roles that work together so that everything works well. And a domain that we all know very well is a Blackboard domain as well. Our software development, we have no clear process, but we all work on the same source code basis and change things. Of course, we like to have split bounded context, but anyway, you understand what I mean. If you think about communication software such as Teams and Zoom or others, there are as well Blackboard domains, and computer games, of course, are very often as well Blackboard domains. Okay, this was Blackboard domains, and the third domain pattern that I wanted to show to you is something that we found a bit later in some domains, often below the cross-grain process. You may find a variation of the Blackboard domain pattern, and this pattern is not just about working together on one or more business objects, but about explicitly negotiating a common plan. So to create a common plan together, and in general or normally, this plan is created between multiple parties that contribute information and respond to each other's information. So it's not just working on a plan together, but sending information to someone else and talking to him and discussing this information in a group. So this is why we call this the dialogue domain pattern. At the end of this coordination process in a dialogue domain, there is a result on which the participants have explicitly agreed. As a rule, this negotiation process is normally carried out between different companies or between the administration and some companies, or between different parts of the administration. So you have different the roles that discuss and have a dialogue together, not in one company. And then you need a process that is a bit more regulated. You work on the same result, on one result together, but you have a dialogue, and you can not just work on the result like on a blackboard. Let's have a look at some examples. I'm still a bit shocked from this moment we had before. We have a client who created a platform for negotiating ship voyages, especially the schedule of these ships, these boats, how they go from one port to the other. And the negotiation is done between the shipping companies and the ports. So different companies that have to negotiate the planning. When will the boat arrive in the harbor? When will it leave? When will it arrive in the next harbor? So this is a real dialogue that is done between companies. Or if you have the negotiation of the type and delivery and maintenance cycles for major equipments between the dispatchers and the customers, this is as well a dialogue domain. Or if you negotiate long-term construction schedules between management and construction applicants, this is as well a process like that. If you build a software system for such a domain, you should think about a dialogue domain. And some games fall into this category as well. I have an example for this for you. In recent years, our company has developed a product for coordination of construction works on the roads for different large towns in Germany. And one part of the system is a touch table, as you can see it here, to make it possible that people from different organizations like the town, the water pipe companies, the telecommunication companies, that they meet and discuss their construction work together. In this product, the domain model is very well designed. So we have a very good domain model for the construction work, for the roads, and for the planning. But the process level, at the process level, the product is still very young in its infancy, because none of the stakeholders at the beginning had any idea how this cross-organizational process, how this could work. And so initially, our software functioned as a blackboard. In the beginning, the construction site coordination across organizational boundaries was more of a mapping of all sites and negotiation among each other, how to integrate the individual construction methods into the overall plan. And this process was relatively chaotic. After 2 years of working like a blackboard, the domain experts began to introduce processes with quality gates. For example, certain states of the process at which there must be a positive statement or an approval of all sides. And so from our point of view, the overall process changed towards a dialogue domain. So what you can see here is that the domain patterns can develop as well over time. For us, it was interesting to observe here that on the one hand, the software drives the domain. And on the other hand, it lags behind the development. So I will show you the domain got into this blackboard idea because we gave them a software. We gave them a software where the users from the different companies had an overview over all the construction work in their sector. They didn't have that before in the whole city. They only had Excel sheets with dates and they looked at maps, and this was all they had. So here the software was a driver to help them to think about their work, to work better, because they could put construction work together in one road for the same moment and could only one time dig into the street. And they could start to think about organizing processes. So what we describe here is a young domain that is slowly evolving because of the software from a blackboard domain into a dialogue domain. Since the domain, as I told you, involved the coordination between different companies and authorities, they started to put in a process that you can see down there with the quality gates, and our blackboard domain moved towards a dialogue domain, but this part of the dialogue domain was not in the software, and there the software was later. It had to follow the development of the domain, and you can see how the software makes possible this development, but then it has to be enhanced as well. The second dimension we will look at is how is the domain model implemented. If you want to decompose a software system, so how the domain model is implemented in the software. If you want to decompose a software system, you will have more trouble with systems where there is a central domain item than with domains that have naturally formed special domain items for each department or for different parts of their domain. As an example of such a central domain item, I will use container terminals. We have a lot of them here in Hamburg, and probably as well in your area. What you can see here is an automated container terminal. We have several of them here, and it's very impressive to watch these machines at work there. What do we see here? The container vessel that delivers the containers, the gantry crane, which unloads the containers from the vessel, the automated guided vehicles with which the containers are driven from the quay to the storage area and from the storage area to the train, the rail-mounted gantry crane that lifts the containers from the automated guided vehicles and stores them until a truck will arrive to take them away, and of course the train cargo where the containers as well go off. What is the problem of this domain? Well, the problem of this domain is that the most important thing is the container. And of course, in the system, in the old legacy system, there is a container class, and you can do a lot with this container class. You can register containers before they arrive by truck, train, or vessel. Loading and unloading from the container vessel is also stored and organized with the container class. Unloading from the truck and customer clearance, all done with the container class. The storage and transfer by crane and other vehicles, moving the containers around in the yard, everything is done with the container class, and the architecture, the overall architecture looks like this. Everything is working on the container, like the central domain class. This domain is very difficult to cut into pieces. A different domain, which is not like this, just to show you the opposite, is the banking domain. In the banking domain, there are various divisions such as account management, credit business, security business, etc., which all have to do, of course, with the customer, but whose products differ significantly. A credit is something completely different from a security, so no one would try to create a unified abstraction for this or use a single class bank customer in all subdomains. For domains with central work items, it is especially important to focus on the behavior rather than on the data. Our goal, especially for work items that appear central, is to always build specific models for the same things for the different bounded contexts in the end. So as a container software system should as well have these bounded contexts, like this banking example, with specific containers for all different bounded contexts. In some software systems, it can be observed that the domain model consists mainly of forms. Such domains are often found in administrative software, for example, in the processing of applications of all kinds, or in recording, checking, and approval of tax returns. These form-based domains and their domain models are often organized in a pipeline-like manner. You remember the pipeline domain pattern. Such a domain model usually emerged because the previous paper-based work is modeled into the software. Usually, these are old domains where people have worked with paper forms for a long time. The implementation of these form-based domain models is most often done with CRUD applications. Create, read, update, delete. So you don't really have behavior-driven classes, but you have CRUD classes in there. The user fills in data into a form and stores it. And in many cases, therefore, the division into modules or bounded contexts does not really make sense. Certainly, there are domains that need CRUD applications, but from our experience, less often than you would find them in practice. What must be understood about forms is that the forms themselves are already a model of the core concepts, like the containers, or a model of a process of the domain. Sometimes forms are things to make notes on, so they are models of a process. In most CRUD applications, this leads to the fact that the domain behavior has slipped into one level higher, into the application layer, or if it is really bad, it has slipped into the user interface, which is really horrible. If you were to clear up a shattered business logic like this, like it looks in our example, you really have to get down the business logic, the domain behavior into the domain model again. And this is really hard work. But if you want to split the thing into different bounded contexts, you have to do this. There's no other way around. And the final part of my talk is about the shape of the domain. What can we find there? What different ideas do we have? The first point is that some domains have been completely digitalized in recent years, like the insurance domain you have looked at. So there is no real work anymore. There is no, real world. There are no papers anymore, no printed contracts, no things outside of the computer. Text collection is the same, banking is the same. So no objects in the real world anymore, and only data and processes in the digital work. in the digital world. Then there are domains where you will always have real world objects in transportation and logistic, of course, when you deal with cars, machines, and control centers, or as well in healthcare. So in the software, you only have representations or simulations of the reality, and you have to keep them in parallel. And finally, digital by nature. Social media or software development tools. Here you have no real world examples that exist anymore. So what I have showed you today, so this is my summary and we can come up with questions, is I have showed you domain-driven transformation in a nutshell. If you want to learn more about it, look in our book or write to me. I can point you to some other presentations of domain-driven transformation in a longer talk. My main focus today was on dimensions of domain patterns. I have showed you pipeline domains, blackboard domains, and dialog domains. I have talked to you about the difficulty to cut into pieces or to break down a software with a central domain item. I have shown you the problems with form-based domain items. I have showed you how difficult is the question, or how important is the question, how digitalized my domain has become. Is there still are there still real objects, or is everything in the software? And two more points that I didn't get to today is the question, how old and how mature is my domain and my software, and how much development potential is in there. These last 2 points, you can find out some information as well in our book. Thank you very much. I'm sorry for the little breakdown in the middle, and now I'm there for questions.
Thank you, Carola, for this great presentation. And it was just 1 minute, so it's okay, I think.
Thank you very much. I'm so sorry.
From my side, I hope the audience
sees
in the same way. Yeah, we have one question for you.
Yes, please.
The question is, what software did you use to create the cloud showing class entanglement?
Oh, yes. This is a tool to analyze software systems, and it's called Sonargraph or Sonargraph. You can find it in the internet when you type in the name. But if you don't find it, send me an email. I mean, you will find me, of course. You will find my email address. It's all over the place. So it's a software analyze tool that you can find out there.
Thank you for answering this question. That's all for now. And
yes.
Seems to be all questions are answered and everything is clear. And thank you for being with us here. And
thank you, Mirko.
Thanks to everyone for attending this session.